from last class. Okay? Just turn it in at the end of class. But for right now, get yourself a calculator handy because we're going to start learning to use the calculator.
I stole a copy of yours. Did you print that out? That's
Somebody might have. Did somebody print out a chapter 3 part 1 set of notes and doesn't have it? Because that's where we're starting, is the third page of those notes. Does somebody need that? You? Actually, maybe put that over there would be better. Okay. Now what we did last time was we did the first 2 pages of this. Just that everybody's coming in at the right place. We did the first 2 pages of this where we did the measures of center. We did the thing with the air conditioner. And we did it with and without the $840 Super Cadillac Deluxe model air conditioner, because we wanted to see what happened to the mean, median, mode, and mid-range when we left that one out. And then we did standard deviation for 3 different sets of data. We did a dot plot of the data set itself. And then I showed you how to actually calculate standard deviation for those. That's on the recording. I haven't posted it yet, but that's on the recording. So if you need to go back and catch up a review, that's there. So where we're picking up now is now we're going to go straight to the calculator. Because the point to doing all of this is not to be able to do a bunch of formulas. The point is to know what these numbers that we get out of this mean. What do they actually mean? Okay, so here's what we're going to do. We have the closing price for 2 different stocks. And what we want to do is we want to compare the performance of those 2 stocks. So what we're going to do is we're going to go into the calculator, go to the edit screen, and in list 1, we're going to enter stock A. And then after you've entered them in, scroll back up and make sure that you've entered all of them in correctly. Remember, bad data entry skills means bad answers. You don't want bad answers. And then in list 2, I want you to put stock B. Oops. Okay, and I must have left one out because my list is too short, so. Okay. Now, if you were going to be investing in the stock market and you're looking at these 2 stocks, let's suppose that you're trying to decide which one of these 2 stocks do you want to buy. Okay? And the closing price is the price that the stock was selling for at the end of business. And this is on a, this is in the same range of days. This is just 10 successive days of stock prices. So stock A started out at $56 and stayed that way for a couple of days. Then it went up $1, then it went up $2, then it went up $3, and then it went up $2 and it stayed the same. And then it went up $4 and stayed the same for 3 days. Stock B, on the other hand, started out at $33, then went to $42, then went to $48, then went to $52, then up to $57, then increased by another $10 to $67, then another $10 to $77, and then another $5 to $82, and then jumped another $8 to $90 on the last day. Okay? Now, are you going to base your whole decision on what the selling price was on the 10th day? What might happen tomorrow? It might drop. Okay? They do that. So, would you want to base your decision on what a typical price for stock A versus stock B is? Or in other words, the mean price, the average price, a central price for those 10 days? That would be one place to start comparing. So what we're going to do first is we're going to find the mean, the median, the mode, and the mid-range, and the range for both stocks. And we're also going to find the standard deviation. Okay? We're going to do all of this with 2 quick calculator routines. You're going to hit Stat. You're going to right-click to Calc. You're going to choose 1 for one variable statistics. And because we're looking at 2 different lists this time, we're going to use list 1. So we're going to be very specific that we're looking at stock A. So for stock A, and I'm just going to record these up here at the top. For stock A, the mean price, and it is an X bar because this is a sample of stock prices. The mean price is 61.5. And I'll make a note, even though we don't necessarily understand what it is yet, we'll make a note that the standard deviation of the stock prices is 4.576, which we're going to round that to 4.58 because it's money. So we're going to call that $4.58. So both of these are actually dollars. And then we're going to go down arrow, and we will come back later and look at something else with these numbers. We're going to go down arrow, and we're going to look at the minimum value of the stock was $56, and the maximum value of the stock was $67. So that tells us that the range is $67 minus $56. So the range is $11. Okay? And then we're going to notice that the median stock price was 62. Now, we can't find the mode with calculator. It doesn't help us. But fortunately, these are listed in such a way that we can pretty well see what happened. And we see that we have 2 days that it was 63 and 2 days that it was 56. But there's 3 days that it was 67. So the mode is equal to 67. Then we're going to move to stock B. So that means we're going to go back to Stat and over to Calc. And again, choose one variable statistics. Only this time we're going to use list 2. So in list 2, or stock B, the mean is again 61.5. But this stock standard deviation is 18.31. In other words, $18.31. The range for that stock is 90 minus 33. And 90 minus 33 is 57. Somebody want to check my math? And then we see that the median again is 62. And looking at the data itself, we see that the mode, let's see, the only thing that shows up twice is the 67. Of course, these are all dollars. Now, if all we look at is the average price, do you see any difference in those two stocks? If all we look at is the measures of center, would you think that there was any difference in stock A and stock B? The median of both stocks, 62 bucks. The mean of both stocks, $61.50. The mode for both stocks, $67. Which one should you buy? Does it matter? If all you look at is the measure of central tendency, you better look at the deviation. I would not be one to be buying stock B. And the reason I wouldn't want to be buying stock B, even though it looks like it's rocketing in price, if you do any stock market reading, or if you know anybody that invests in stocks, you want stocks that perform consistently over the long haul.
Unless you're a day trader and you buy the dips and sell.
Okay, now if you're a day trader, if you're not in it for the long haul, if you're a day trader and you notice that stock's performing like that, remember what you want to do is buy low. We're talking about buying.
Yeah.
You want to buy low and sell high. So buying low, well, yeah, you could have bought stock B cheap, but you better dump stock B at the end of 10 days. Because you may come in on day 11, it's back down to $23. Stock B is for something that is a sudden trend on the market. Everybody's buying it, like the little finger spinners. Everybody's buying it. You think they're going to keep buying those things forever? Sooner or later, everybody's fascination with them is going to fade. It's going to go the way. I'm tempted to say it would go the way of the Rubik's Cube, but Rubik's Cubes have been enjoying a nice little revival lately. So, but you know, it's a fad. Stock B is something that's a fad stock. If you're investing for the long haul, you buy stock A, and hopefully it steadily increases, so that when maybe you're buying it to be able to sell them later for your down payment on a house. Well, you want steady, consistent growth. If you're buying those stocks to invest in for your retirement, then you want steady, consistent growth. Stock B is risky. And the reason stock B is risky is because it has a large standard deviation compared to stock A. Its variability is measured by its range and its standard deviation. So if you're looking for consistently the same slow, steady growth, then you're looking for stock A. Now, in order to see what it is these are measuring, because it's not always plain to us what these are measuring, what I want you to do is the same thing we did last time. I want you to make a dot plot of each stock price. So for stock A, we've got lots and lots of tick marks here, but I want you to keep in mind, we need to make stock A and B on the same set of number lines to be able to compare them. So if I need to get from about 30 to about 90, well, I'm not going to do it counting all those ones, right? So it looks like I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I've only got 24 marks. So if I let each one of those marks, if I started at 30 and let each one of those marks be 2, I still wouldn't have enough. So I'm going to have to let each one of these marks be 3. Make sense? So we're going to start out, and actually there's no reason we have to start out at 30. We can start out at 33. And that's 36, 39. I'm going to label just every other one. And then 39 plus 3 is 42, so this would be 45, 48, 51, 54, 57, 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93. Okay? Then I'm going to label the ones on the lower one the same way. So I'm only labeling every other one, just so that I don't have to write so tiny. Now I want you to take the numbers for stock A and stock B, and I want you to plot them where this is stock A, and the bottom one's stock B. So I'm going to start out stock A. I've got two 56s. And since this is 57, 56 is probably right about here. And then I have one 57. And then I've got a 58. And then I've got a 61. And then I got two 63s. And then I've got a 67. That needs to be a little bit over that way. And another one. And another one. Now I can't say this is more or less spread out at this point because I need to have something to compare it to. So I'm going to go over to stock B. So on the first day it was 33. Then it jumped to 42. Then it went to 48. Then it went to 52. Then it went to 67. and stayed that way for 2 days. Then it went to 77. Then it went to 82. And then it went to 90. Can you see visually how much more spread out stock B is than stock A? The range for stock A goes from here to here. The range for stock B, on the other hand, is much wider. But the mean, the median, and the mode were all exactly the same for both stocks. The mean for stock 1 was $61.50. And for stock 2, it was $61.50. And the mode was $67. And that was for both of them. Actually, it was, yeah, I kind of messed up that one too. Let me move his little buttons over a little bit. So actually the mode was that 67, I just didn't have it in the right place. And then the median was $62 for both of them. Actually, the median should be on the other side. Sorry about that. So the median's a little bit further over. So their centers are all in the same place. Yes.
Can you slow down a little bit? We're kind of
Okay. Do I need to back up to somewhere?
It's more like just,
When you start doing whatever you do.
yeah,
Okay, about where they are?
yeah, pretty much.
Okay, look at the fact, okay, let's first talk about what is a mean, median, and mode. What do they measure? What do they measure? If I talk about the mean or the median or the mode age for this class, what am I talking about? The average.
And then median is the middle.
The middle, but that's also an average. It's just a different, the word average, the way that we use it, it's actually very imprecise because all three, mean, median, and mode, those are all measures of average, measures of typical, okay? If you were to walk into a college classroom and you were going to pick out a typical student's age, what do you think that student's age would be? 19, 20, 21, something like that. Now, does that mean that there's not going to be anybody in there that's 18? No, that's still within normal. Does that mean there's not going to be anybody in there that's 25? No, that's still within the realm of normal. If I walk into the classroom and I look at a student and I see that one of those students is 69 years old, would that give you a little pause to think like, wow, what's that person doing here? They're out of place, right?
Maybe an outline.
That's an outlier. Now, does being an outlier mean that's impossible? No, because actually this summer I had a student in my class, my math class this summer, and she was older than 69, she was 73. She was coming back to school because her husband had passed away and she was trying to figure out how to manage her money. She'd never done it before. So, you know, is she a typical college student? No. She's a very unexpected college student. But she's still an outlier. Doesn't mean she is what we expect to see, okay? A lot of what statistics is to teach you, you know, what do you expect to see? You expect to see things like the mean, the median, and the mode, okay? This data has a broad range. This data doesn't. This data has a large standard deviation. This one doesn't. It has a small standard deviation. The difference in the range measurement and the standard deviation measurement, how much, excuse me. I wish I just sneezed instead and been done with it. How many numbers, how many of your data values do you actually use to calculate your range? Two. Which ones? The biggest one and the littlest one, right? The extremes. How many of your measurements do you use to calculate your standard deviation? All of them. Every single one of them. Everybody counts. So the fact that these two numbers are so spread far apart, and this goes back to what we talked about with the air conditioner, just because you have a large range, you will have a larger standard deviation. But if that large range is due to an outlier, then if you recalculate without the outlier, you'll get a much better measure of center and a much better measure of spread. So what I wanted you to get out of this was, number one, how do you do this stuff in the calculator? Because we're going to do this a lot. But number two, I'm trying to get you to start thinking about what these numbers mean. You know, in context of a problem, what do they mean? What do they measure? Okay?
Does that have anything to do with variance?
Yes, but standard deviation is the square root of the variance, and the problem with variance is it comes out, if this was in stock prices and we're talking about the variance of the stock prices, then it comes out in square dollars.
Okay.
Because the standard deviation is the square root of the variance. And that's really all you need to know about it is if you're given the variance for a set of data and you need the standard deviation, you take its square root. And if for some reason anybody ever wanted to know the variance and you got the standard deviation, then you just square the standard deviation to get the variance. You just need to remember the relationship between the two. But the variance really doesn't help you with, it's hard to conceptualize what it measures,
Okay.
okay? But standard deviation is, the best way to think of standard deviation is the average amount of every single piece of data. How much does it vary from the mean on average? And what that tells you then is, in this case, 33 varied from the mean quite a bit. These numbers here didn't vary all that much from the mean. Okay? That other stock that we have down here, when we got a large standard deviation, remember the means here, look how far away all these data values are from that mean. Look how far, if this is the mean here, look how far these are from the mean. Despite the fact we've got a couple that are pretty close, most of them are pretty far away. Whereas here, here's your mean. Look how close all the data values are to the mean. And that's why your standard deviation is really small, because we're talking about the average distance that everybody gets from the mean. Now, still working with the same set of data, it's still in your calculator. Let's go to the next page. It says construct a box plot of the data and list the 5-number summary. Find the interquartile range, that's what IQR stands for, and I'll write that down, and list any possible outliers. Show your work and don't forget to label the graph appropriately. Okay, first we're going to write down the 5-number summary. That's the 3rd page of the notes, I think. Yeah, that's the 3rd page of the notes from last time. You don't have that? Let me pull the notes back up and make sure that actually belongs there. It's
Oh, that's the manatee worksheet.
Ah, you're right, it is. That's the manatee worksheet. Okay, let me get rid of that. Let me get rid of that. But since you're going to have to do it on the manatee worksheet, okay, since you are going to have to do it on the manatee worksheet, let's go ahead and build a box plot so I can tell you what all this stuff means. We're going to just stay right here. Just take notes. We're going to stay right here on the same page that I just left. And let's get the 5-number summary for both data sets. Now, we've actually already got 3 of the 5 numbers. This is for stock B. This is its 5-number summary. The 5-number summary includes the minimum, which we already had. We've already used it. The maximum, the median, which we've already calculated and used. But it includes 2 more numbers. It includes something called Q1 and Q3. Q1 is the median of the lower half of your numbers. The best way for you to understand what Q1 is and Q3 is for me to show you what the box plot actually does and what the 5-number summary actually does. If I start out, and we're still talking about stock B in this case, if I start out, the highest value of the stock was $90, and the lowest value of the stock was $33. Since there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 stock prices, there's going to be 5 in the lower half and 5 in the upper half. So the bottom 5 are the 33, the 42, the 48, the 52, the 57, 1, 2, 3, 4, 5, and then for the upper one, it's going to be 90, 82, 77, 67, 67, and that's 1, 2, 3, 4, 5, okay? So this is the lower half of your stock prices. This is the upper half of your stock prices, okay? This is the bottom 50%. This is the top 50%, the top half of the data, okay? Notice that the median of 62 is halfway between 57 and 67. It is the middle number between 57 and 67. We don't even have a stock price at $62. That's just a measure of where the middle of the stock, where do the stocks break into the lower half and the upper half, okay? What these quartiles are is the same thing, except it's the middle of the upper half of the data. So if I only look at the upper half of the data here, what's the middle number? You got 5 numbers, which one's in the middle?
48.
Okay. Got 5 numbers on this side. What's the middle number? 77. Okay? This is called the first quartile. This is called the third quartile. There is another word for the median. It's called the second quartile, the 50th percentile. It's the halfway mark. Okay? So median and Q2 are the same thing. When we make the box plot, it makes a picture of all these numbers that makes it a little easier to see how they relate to one another. So what the box plot's going to look like is it's going to start with the 5-number summary. And I'm going to make a number line to make sure that I've got everything lined up. And my 5-number summary needs to start at 33. And it needs to go up as high as 90. So I'm going to try to mark this off to where it's fairly close to what we looked at a minute ago. You have to have it evenly spaced. So assuming all of these measure about 3, that will be 36, 39, 42, 45, 48, 52, 55, 58, 61, 64, 67, 70, 72, 75, 78, 81, 84, I think I went too far. 81, 88, 81, 84, 88, 91 is right here, so I don't need this much of the number line. Here's 90. And here's 33. Okay? Now it's important that this be scaled because you've got to keep this even. So then the other number I'm going to put on here is 62. That will be 33 plus 29, so there's 3, 6, 9, 12, 15, 18, 21, 24, 27, 28, 29. This would be my median. Let's see if I can scoot it up now so you can see better. Then I need to know where 48 is. Well, 48 would be 33 plus 15. 3, 6, 9, 12, 15. And then 77 would be 62 plus 15. So that would be 1, 4. Actually, it'd be easier to go back from here. So 90, 87, 179, 78, 77 would be right here. So that's a box plot. Okay? Now the things that you probably want to take away from this. Some things we can say. %50 of the values are between 48 and 77 because this is 50% of your data. Okay? You could say that 25% of your data is between 33 and 48. You could say 25% of your data is between 77 and 90. But the thing to remember is that what you've done is you divided this into chunks of 25% each. That's what a box and whisker plot does. It divides your data up into chunks of 1/4 of the data values in each chunk. Okay? Now, if we stay with the same scale, and we, yes,
And he said it divides the data values into 25% of the total value of data. So that means that the amount of data values in each of those quartiles is not going to be the same, right?
the number of data values in each one of those is going to be the same, but it isn't necessarily going to be evenly spread out every time.
Okay.
Okay, that's the key.
So the occurrence of data in each quartile could be different? Like
Yeah,
you have
like for
3
example-
values in one, 6 values in another, or something like that?
Well, no, this, since you've got 10 values here total, then it's kind of an odd way to say it, but the first 2.5 are there, but then that's actually the third one. And then there's another 2 here. That median point actually isn't even one of your numbers, but it's just a dividing line between them.
Right.
And then from here to here, you should have another 2 numbers, with this being the third one. And then there's gonna be 2 here. Now, that's not to say that those 2 numbers are gonna be evenly spread out in there. They may be all down here close to this, or they may be up here closer to this.
Okay.
And that's why it's important to have a number line, because where they are in relation to each other makes a difference.
So what does it mean, like, when they say, like, you're at the 90th percentile, what does that mean?
It means, and that's a very good question, I'm glad you asked. It means that since this is your upper 25%, basically here you're at 75%, so my 75th percentile is 77. Okay, I need to go up 15% more to get to the 90th percent mark, right? So that means if you're at the 90th percentile, it means that you're higher than 90% of the people you're being compared to and lower than 10% of them.
Okay.
Okay? So the 90th percentile is a good place to be if you're talking about test scores or credit ratings or something good. The 90th percentile would be a good place to be if we're talking about the total amount of your debt. You don't want to be in that top end of how much debt you have. Okay?
Okay.
But it's a measure of position. The 90th percentile says you're better than 90% of the 90% of the people that have less than you do, and you're a little you're worse off, or you're not at the 100th percentile mark. There's 10% of people in the group that you were in that had a higher score than you did.
Okay.
Okay? I'm glad you asked that. Now, if we talk about stock A compared to this box plot that we just looked at, and I'm not going to draw another box plot, we're going to let the calculator do it for you. So let's go back to the calculator. And remember that your 5-number summary for stock B is not the same as it is for stock A. We already know that at least 3 of them are different. So even though our mean's going to be in the same place, look where the first quartile is. The median is still at 62, but your first quartile is at 57. So that's 51, 54. Here's your first quartile. For the other stock. And your third quartile is at 67. So 50% of the data for stock A are between 57 and 67. Look how much more spread out their middle 50% is. And then if we put in the max and the min, the max, this is both Q3 and the max. So it doesn't go any place higher than that. And the minimum is only 56. So it's only got a little bitty whisker. So if I pull this down here so you can look at both of them kind of on a level playing field, this is stock B, this is stock A. Compared to stock B. Now you don't have to draw these by hand, although you might have to sketch one on a test. What normally we'll do, and you can actually get the calculator to help you with doing this, is you want to go to your stat plots, which is second y equals. Select plot number 1, and we're going to go down arrow to the type, and what we want is on the second row. Whoops. So you actually have to go across to get to the second part, and choose the one in the middle. I know the other one's a box plot too, but choose the one in the middle. And notice that as soon as you make that choice, it only looks at the frequencies for list 1. It looks at list 1's data. So you hit enter, move down, make sure it says list 1, hit enter, and then just stay there. Now we're going to go back and go second y equals a second time, because we're also going to make a box plot for data set 2. So we're going to turn it on, down arrow and across to get to the box plot in the middle of the second row, hit enter, and this time we don't want to make another one of list 1, we want one of list 2. So we go second and L2 to get list 2. And then we don't want to have to figure out what kind of window we need. Your calculator will do this for you. Once you've got that set up like that, you hit zoom and go down to the number 9 key. which is Zoom Stat. See the difference between those two box plots? If this represents A and this represents B, what does that tell you? No, you're not.
Okay, thank you.
Anybody stuck on the calculator? Okay. Gotta get you unstuck. Different distance between, you know, unless you use a fraction. The rule of things, isn't it? You see it? Scroll down to number 9. I think it's above these things. Yeah, you're doing this one. Now it's in 9 again. Has everybody else got it? That's how you make a box plot. What this box plot tells us is that 25% of the data are that little short line right there. So that little bitty distance right there represents see if I can pull this to the side for a second. That little bitty short whisker represents those are your numbers. And then this chunk right, come on mouse, that chunk right in here represents all of those numbers. But then that other piece above that, right here, it essentially represents all the rest. Because they were all the same value. So you didn't have much spread there. Okay? So if you're talking about the numbers that are actually in this little short line here, that's those numbers. Because the 48's actually kind of like on the dividing line. And then that next box up, that first half of the box, represents these numbers. And then this side of the box represents these numbers because the 77 is the dividing line. And then that, whoops, come back here. How dare you turn off in the middle of my lecture? So that upper whisker that the other one doesn't even have, that little chunk right there, that represents these numbers.
We can go over the calculator.
Sure. In fact, since you're gonna have to do it, let's go ahead and get you set up to do the manatee worksheet. I'm trying to find it. I don't think I have it, so let me pull up a copy of it. So go ahead and get your manatee worksheet.
Anything else in there? Got it all. All of it?
Yeah.
Okay, did it charge you? I don't really know.
Calculator. Oh, this one. It just starts at this 2%. I'm like, my list one is up here.
Okay, here's how you put it back. Hit your stat button. Go down to setup editor, and hit enter twice. Hit enter, just hit enter again. Okay, now go back to your list. Hit enter.
Oh, there it is. And then to clear that out, I hit clear, right?
You hit delete if you're in the list or clear if you're on top of it.
No. I think that's what it is wrong. Clear.
You deleted your list instead of clearing your
Yeah.
list. Clear means dust it off and, you know, throw away the crumbs. Delete means throw it away. Okay. Everybody got your manatee worksheet now? Enter your data into a list on your calculator. I do not care which one. I'm going to use list 1 because we're finished with the stock price problem. So So I'm gonna get rid of the data that's in list 1. So enter your data into list 1. Make sure they're right. Look up when you get done so I know you're finished.
Always
Wow.
put in L1.
I just put mine in L1, you put it wherever you want to. We're done with the stock data anyway, so you can top over. It's a short list of data, so it shouldn't take you long to get it in. Does anybody not have it in yet? Okay. Here's your steps. You hit your second and your Y equals button. You press enter to select plot 1. If it's not already on, if it says off, then you need to put the cursor on and press enter to turn it on. And from there you have to go down arrow. What we want is the one that's down here. So if you have this one highlighted, that's not the right one. What you have to do, and on type, you have to go right arrow to cross. You can't go down arrow as much as you'd like to. Down's going to take you to the next thing. So go right arrow until you land on that one, the middle of the second row. Now, as soon as you hit down arrow, your calculator screen is going to change. It does if you have sense and hit enter while you're sitting on that graph. Okay, so as soon as you hit enter, that screen changes. The next thing you do is, if this doesn't say list 1 and your data's in list 1, then you need to make it say list 1. If you put your data in list 5, then you need to make it say list 5, which is second and the number 5, because you're telling it where your data is. You leave the frequency alone. Don't mess with the frequency. Don't change the frequency. Okay? Then the next thing you do, and this is important, hit your Y equals button and make sure that there's only one plot on, and that's plot 1. If you see 2 black boxes, and I know most of you do right now because you put 2 plots in there, what you need to do is put your cursor on the one you're not using and press enter to make sure that that one's turned off. Okay? So your steps: get your data in, go to plot 1, turn it off, pick the box plot if that's what you're wanting to make, tell it where your data is, then hit Y equals and make sure that the only thing that you see on those plots is plot 1, not plot 2 and 3, just 1. Okay? Then you hit your zoom key. Zoom key is related to your window, to your viewing window. It's how you set it up. Most of you, if you've used it, the calculator in algebra, have used these up here. You've never used Zoom 9. If you go down all the way toward the bottom of the list, you see Zoom 9. Zoom 9 says Zoom Stat. That particular Zoom is hooked to the stat plots. What Zoom 9 does is it goes and looks at the data that you're trying to make a graph of. It calculates the lowest and the highest and other things that it needs to know to set up the window, and it sets the window for you rather than you having to set up your window. So when you get down to number 9, just hit enter or just type a 9 to start with. So here's your manatee box plot. Okay? There's your manatee box plot. Now, if you want to know your 5-number summary, and you don't want to have to go back and calculate your one variable statistics, if you hit stat or hit trace while you're on the box plot, it's going to pop up first at the median and tells you that the median for those manatees is 80. If you left arrow, it goes to your first quartile. So it says that 25% of the manatee deaths were between 73 and 80, I think was what the median was. So that's the point of that. That gives you markers for 25% of your data. The minimum was 69. So 69 manatee deaths was the smallest number that happened. If you go right arrow, you go to the third quartile, half of the manatee deaths is between 92 and 73. So 50% of the data they collected was between 72 deaths and 90, or 73 deaths and 92 deaths. And then the maximum number of deaths in any one year was 97. Okay? Now, if anybody in here is interested in marine biology or interested in conservation, manatees are not a useless animal. They are a valuable part of the ecosystem, and unfortunately, the way that they like to live causes them to get killed because they are in waterways where people run power boats. And because they float near the surface, the power boats hit them and kill them.
They did pull them out of the endangered species list though.
Yeah, they did, but primarily because they started preserving their habitat.
No, they closed off a lot of the water.
They closed off a lot of the waterways. So what you want to do to finish this worksheet then is you want to record all those values. And then where it says use the range rule of thumb to determine whether a death of 101 manatees in a single year would be considered unusual, what you want to do is you want to take the mean, multiply the standard deviation by 2, and add it to the mean. And anything more than that means that it would be unusual. So you can calculate that on your calculator. You go over to your one variable statistics, and we're using list 1, so I can just hit enter. So it says the mean is 82.7, and the standard deviation is, we're going to call that 10.1. Okay? So the standard deviation is 10.1. 10.1 times 2 is 20.2. And if I add 20.2 to 82.7, that's 102.9. Okay? So would 102 deaths be, or 101 deaths be considered unusual? The answer is no, because it falls less than that. Would 103 deaths be considered unusual? And the answer to that would be yes, because it's more than 102.9. Okay? Then you're going to construct the box and whisker plot and do the 5-number summary. Now what I'm going to do, because it asks you also to find the interquartile range and list any possible outliers. Okay, the interquartile range for this set of data so that you'll know how to do that. The interquartile range, which is called the IQR for short, is Q3 minus Q1. Inter means between, and quartile is the quartile. So it's basically the distance between the quartiles. So since our Q3 value is 92, and our Q1 value is 73, then the interquartile range is 19. Now, when it says list any possible outliers, there is another way to find outliers. That unusual value where you add 2 standard deviations to the mean and subtract 2 standard deviations from the mean, that's the range rule of thumb to find outliers. There is another way to find outliers. So let me see if I can sketch you a picture of your box plot. You've already seen what it looks like. So here's my number line. And 69 is my minimum value, so that would be about here. And 97 is my maximum value, that would be about right here. $80 is the median. And 73 and 92 are the quartiles. So there's the box and whisker plot. That's what yours is going to look like. That 19 tells you how wide the box is. Okay? It's the width of the box. The box goes from 73 to 92. That's what IQR tells you. Now when it says, see if there's any outliers, this is what it wants you to do. It wants you to take the interquartile range, which is 19, multiply by 1.5, the 1.5 is part of a formula. It's 28.5. And then I want you to, then what you want to do with that 28.5 is you want to take your lower quartile, your Q1, and subtract 28.5 from it. That's 44.5. And then you take your upper quartile, which is 92, your third quartile, and you add 28.5 to it. And get 120.5. These are called your upper and lower fences. Anything that's higher than the upper fence or lower than the lower fence is considered to be an outlier. This data set has no outliers. And the reason it has no outliers is because if I extend my number line down here a little bit, here's 45. And my upper one is well, no, not quite. I'll have to extend my upper one too. I'll have to get the calculator out of the way. So this would be 110, 115, 120. And our upper fence is 120 and a half. And our lower fence is 44 and a half, so it's actually right on the edge of my paper. It's actually below 45. So all of your data is inside the fences. That's what that says. All of your data is inside the fences, therefore there are no outliers. Okay? The other one that they ask you to calculate, just to be sure that it's actually written down in here and not just hearing me talk about it, is the range rule of thumb. So you can take some notes. Which says that you take the mean minus 2 standard deviations and take the mean plus 2 standard deviations to get the same thing as the fences. So your mean is 82.7 minus 2 times 10.1 to the mean, which is 82.7, plus 2 times 10.1. And we already decided that that was 20.2. So when we add these together, oh, wait, subtract that one, sorry. We get 62.5. And when you add 20.7 to 82, you get 102.9. So all of your data are still between those. Okay? All of your data is still within those two boundaries. Your largest data value is 97, which is inside that, and your smallest data value is 69, which is inside that. This is a much more conservative rule. If we mark where those are on your box plot, because your box plot is a picture of all your data, your 62.5 is right there, and your 102.9 would be right here. So this is your range rule of thumb. It's just another way to try to determine if you have outliers. But please remember, just because you determine there are or are not outliers doesn't mean you automatically throw out that suspicious piece of data. Because if you do, that's still a legal piece of data unless you know for a fact that it was not correct. Unless you can actually go back to the person that collected the data and they say, oh, I must have written that down wrong, or I wrote that down backwards, or somebody typed it in wrong. Then you can eliminate that piece of data, or you can correct it. But just because it's there and it looks strange doesn't mean that you can't, that you shouldn't use it. You should. You should always acknowledge the presence of an outlier. And in fact, I've got an example that I'll post up in Shobi for you. It's an article to read that'll kind of show you the importance of outliers and why you don't want to just throw them away. We're getting not to the end of class, but we're getting to the point where I want to tell you what you need to do. Go away, Chrome. Okay, I'm going to finish up this class period because I'm going to finish up most of it. I'm going to skip over some of it. But what I want you to pay attention to, you need to do the calculator practice. Okay, you need to do that one for homework. It's basically the things that we've done today, and it's all on the calculator. But I'm going to do a problem like this one so you'll know how to do that problem. Because right now you don't know how to do it. And I want you to finish this one for homework because you can finish this one with no problem. You should be able to do all of those. We've been through all of that. So let me go backwards for just a second, so I can show you how to do that problem on the calculator practice that you don't know how to do. And I need a set of data to do it with. Okay, that was not what I wanted. Has anybody worked on this one yet? This was homework that you should have done. Okay. Let me download this one and print it out just to get the frequency distribution. And I'll have the answers to this posted by this evening. I just don't want to take the time out now to go ahead and post them. So I'm going to let y'all tell me. Since there were 2 people that raised their hands, I want y'all to confer and make sure you agree. Because I'm going to ask you to give me your frequency table. What was your first class? Okay. So then the next one begins at 95, and let me see if I can construct the rest of it and it matches yours from what you just told me. 95 minus 26 is 69. So was your class width 69?
Yes.
Okay. Good deal, you got that right. So 26 plus 69 Is that right? I see.
The 439 there or the highest number?
The 439. Because these all have to have the same potential possible values. Okay? So when you counted them and got your frequencies, tell me your frequencies.
For the first one, I had 5.
Okay? Second one?
6.
Okay. Third one?
7.
Okay. Then 1 and 1, 4, and then 2. Okay. Now I'm going to ask you to do this after I'm finished, not now. I want you to actually, when you get home, even if you have, and it's not part of this assignment, but when you get home, I want you to actually calculate the mean and standard deviation of this whole set of data. But for now, I want you to pay attention to what I'm gonna tell you to do. I wanna use the calculator assuming that I no longer have the data. I collected the data, I wrote it out on a piece of paper, and I lost it. But I have this frequency distribution we made. Can I still calculate mean, median, mode, standard deviation, type number, summary? You need the midpoints, good. So what I need then is I need to find the midpoint of 26 and 94. And that's 60. And since my class width is 69, then the rest of them I just add 69. So there's the midpoints. Now here's what I want you to do. All of us together. Hit your stat button. Go to your data screen and enter the midpoints in list 1. And then in list 2, I want you to enter the frequencies. So that was list 1. That's list 2. Okay? Now we're going to calculate one variable statistics. Now here's what's important. If all I do is hit one variable statistics, oh my gosh, y'all can't even see that. Get that back down here. If I calculate one variable statistics and I just hit enter right now, what's going to happen?
List 1 to be list 2.
That's right. List 1 will be the only one that's there. List 2 won't be there. Does that matter?
Yes.
Yes, it matters a lot. Because that tells me how many of those numbers that were in list 1. Okay? Because how many bare weights did you have in this whole set of data? Had 25 of them, right? How many numbers are in list 1? 6. That's not the whole data set. So you have to have the counts. So you do put in list 1, then you have to put a comma, and your comma is above the number 7 key. And then you have to hit second 2 to add list 2 to that. So it has to say 1 bar stats, list 1, list 2.
I'm already in the list thing. How do I get out of there? I've been in there.
Second, and then the mode key. It's right next to it. Second and the key next to it. That takes you back to the home screen. Okay? And then hit stat. And then over 1 to calculate. Choose one variable statistics. Then second and the number 1 key to get list 1. Then a comma. And then second and the number 2 key to get list 2. Okay? So is everybody together now? Hit enter. So the mean weight of the bears was 195.24 pounds. The standard deviation was 109.96, which we could call 110 pounds. 110.0. Notice that N says there's 25 pieces of data in there. That's important. Because if we hadn't have put both lists in there, it wouldn't have thought it had 25 pieces of data. It would have thought it only had 6 pieces of data. Okay? And then you can still get your 5-number summary and your median. And those are actually going to be fairly accurate. What's going to be off a little bit is going to be the mean. So when you actually take all these numbers and put them in a list and you calculate this same set of one variable statistics, all of them won't match. I want you to come back on Monday knowing which ones of them don't match. And if you don't understand why they don't match, be ready to ask why. Okay? Because I know you can do this part. I know you can calculate one variable statistics. It's a matter of entering the data. You can calculate one variable statistics with the list too. But I want you to understand that when you do it with all the data and when you do it with a summary of the data, some things aren't going to match. Which ones are they and why not? And are they close? Are they close? Does it come close to matching? Because it should. Okay? Now, so that you're aware and so that you can start getting caught up. Test over chapter 1, 2, and 3, 1 week from today. Next Wednesday. We have one thing left to do on Monday that I want to be sure that we've included. Plus, I want to look through what's on the test and make sure that we've covered every single thing. I will go ahead and post the practice test this weekend so that you can work on it. Yes?
Only the calculator practice and manatee was only.
Yeah.
Is all.
It's all, anything we haven't already done is homework.